Okay, so let me go to the new share. Commitment, where is that? Open it. Okay, so this is our new topic. Okay, unit commitment, the next topic in our syllabus. Uh, let's start this with some nice figures. So this is very well known. Okay, the first slide here, it is very well known to us that loads are actually fluctuating in nature. In the economic load dispatch problem, what we did basically, we took a single value of load, right? Some megawatts of P demand at a certain instant of time, and we tried to find out the most economic combination among the available generating units to satisfy the demand. And lastly, we saw plus some losses, demand plus losses. But of course, loads are not constant. If you see the load profile, let's say, if you see loads are varying in throughout the day, actually throughout every minutes of a day. Okay, loads varies in the weekends and in the weekdays. The variation for the weekend load and the weekdays load are pretty different. They have different peaks. Okay, you see the weekday peaks is much higher than the weekend peaks, and the weekend peaks, you see people, you see in this area between 10 a.m. to 4 p.m. you see it's much larger than the weekday values. Of course, this is for some arbitrary place, and this will of course vary from place to place. Okay, but this is just for a sample. Okay, just for a sample, as a sample I am providing this information that loads are continuously varying. So if your economic load dispatch, let's say the last example, we solved it for, let's say, 850 megawatt, but I mean, in practice, the load is never fixed at 850 megawatt. Okay. So on the right hand side, we are showing you the diagram where the loads are also dependent on seasons. Okay, seasons and years. So in the summer season, you expect some different profile throughout a day. In the autumn, you have a different profile, and so on. In the winter, in the spring, and also from place to place, these curves and peaks will also vary. So what is the, I mean, what is the takeaway from this slide is basically our load is never constant. So if I only solve the economic load dispatch and remain satisfied, okay, I have got the answer, I am supplying 850 megawatt, my generations are within limits, my loss is minimized, so I'm done. But no, in the next instant, or probably in the next hour, my load is going to be changed. So how to tackle this issue? Or more precisely, is this a problem, or will it cause a problem in the operation of an electric power system? Of course, it will create a problem because load is changing. So if the demand changes, I can't stay with my previous generations. Okay, I can't stay with my previous generations. If the load is increasing, let's say in this car, the load is increasing from 4 to 6, load is increasing. I can't say, well, I'm only supplying this much of demand, that's enough. My demand is increasing, so I have to update my generations. Again, after this 8 o'clock, the loads are dropping here. Okay, for the red curve, the loads are dropping, so I have to reduce my generation. So that means I have to play with the generations. I can't remain satisfied with only one ELD solution at a certain instant of a day. I have to look beyond that. So the unit commitment actually helps us to look beyond that point. Okay, this is number 1 point. So now one solution could be like this, that well, if I simply turn on, okay, if I simply keep sufficient units on for the whole day, what is the problem? What does this mean? Okay, let me highlight this. What does this mean is actually, if I look into this, well, if in a 24-hour period, let's say in a 24-hour period, my load maximum demand is how much? Let's say 1 kilowatt for this. Probably this is some residential load, so very low demand. So what is the problem if I connect a generator and if I or few generators, let's say. Let's say this is 1 megawatt, okay, or 100 megawatts. And I have to supply this 100 megawatt from some of my generators. So what is the problem if I just create or generate 100 megawatt and keep them on for the whole day? What will be the problem? Can anyone say?
Sometimes it will be a waste of resources.
Yeah, actually you are losing the remaining power in the transmission network. Okay, so your demand is, let's say here it is, let's say point or 400 kilowatt at this point around. You are generating 1 megawatt or 10 megawatt, so you are only giving, I mean you are supplying only power to this 4 kilowatt load. The remaining portion will be lost in your network. So pretty easily you can say that this solution here, which is provided here, that why not simply commit is explained here, I will come to that point. Simply commit enough units to cover the maximum load and leave them running. This is not economic, okay? This is not economic solution. So what is the meaning of committing a unit? That means we are turning on a unit. First of all, you have to turn on a unit. Remember, we are still in the thermal unit consideration. Okay, we are again coming back to thermal units. So that means we have very big units. You have boiler, you have turbines, you have generators. So you have to turn them on. You have to bring the generator to speed using the turbine and boiler setup. Of course, you have to synchronize it to the system. You know by now, you should know what is synchronization. And you have to connect it to the network. All these things are to be done when you are saying that I am committing a unit. Okay. So the problem is that it is mentioned that the problem is with this approach here. You turn or you commit enough units and you leave them running. But this is related to economics, as we have already mentioned, that will incur losses without any reason. And of course, this is quite expensive to run too many generating units unnecessarily. Okay. So a great deal of money can be saved by decommitting units. That means by turning off the units when they are not required. In short, what this line means, when you have reduced demand, you just turn off some of your units. Okay. So from here on, I think I don't have enough time today. Sufficient is done for one lecture. So in the next class, we will see that what is basically the difference between economic load dispatch and unit commitment. Okay, we'll see with the help of simple diagram. Okay, till then, hope you stay safe and well. If you don't have anything to say, please provide your attendance in the chat box before you leave. Okay. So thank you very much, and please let me know about the quiz date for the quiz, because timing is finalized. So please let me know by today and or tomorrow at best. Okay, thank you. Assalamu alaikum.
When is the time, sir?
Sorry?
When is the time? Say the time.
Time is 7:30 p.m. Okay, 7:30 p.m.
Can we keep it like, or maybe 15 minutes?
I have no problem. It was the suggestion was from your side, so it is not yet finalized. So you may discuss among your groups. You may take polls or opinions, and you can send it to me. The final decision.
Because,
okay.
Because now they have shifted the Isha prayer at 7:30 exactly.
Yeah, this is why I said. So you discuss among yourselves. You finalize the time also, if needed, and you send me the timing.
Okay.
Okay. Thank you.
Okay.
Thank you.